So we can start now. We will start with an introduction to research data management and to our data agent network. So maybe you are wondering what is exactly research data management. So research data management involves all the cycle of life of your data. So it starts with the planning step, where you may need to do a data management plan. It's required by a lot of institutions now, and fundings also ask you to do some data management plan. So it starts with this, and then it's everything about collecting, processing, and analyzing your data, also preserving them, so storing them, and all about the sharing and reuse of your data. One thing that you want to remember is that your data should be as open as possible, but also as close as necessary, because you may have some confidentiality agreement in your project. So what are exactly the data? It can be a lot of things. It can be interview or survey data. It can be text document, drawings, personal data, instrument-specific data, so spectra, for example, code, algorithm, models, reactions, chemicals, all sorts of data. So one thing is that your data should follow the FAIR principle as much as possible. So the FAIR principle is about, first, findability of your data. So you should associate your data with rich metadata to describe them, so that we can easily find them and index them in searchable source. So it's also about the persistent and unique identifier that you can associate to your data. So I hope you all know about the DOI, but another example of identifier is ORCID. It's an identifier for persons. Your data should also be accessible. So it will be accessible thanks to this identifier, but it should also be open, free, and universal access as much as possible. Your metadata should also always be accessible, even if the data in itself are not kept, because after sometimes 10 years, the data are not kept, they are really heavy, but the metadata should remain. It's also about interoperability. So you have to think when you save your data to save them in an open format so that it can be reused in the future. So it's an open format for all kinds of systems. And so you can open it on, for example, Windows or Apple, and anyone can open it. And so this last one is the reusability, and the reusability should be possible if you followed the first steps I said. So now I will talk quickly about chemistry data standards. So there are a lot of standards in chemistry. Here are the main example of standards. I have put on the side an example for the sorbic acid. So you have here the current representation of this molecule and its formula. And you can see that depending of the standard you use, the representation is completely different. So the first one is the one which is mostly used when you order a chemical, for example. So it's the CAS number. But you can also find other standards like INCHI key. So the difference between both of these is that the INCHI standard is a very long chain. So to find it more easily when you search for a chemical, they invented also the INCHI key. So if you compare, for example, the INCHI with SMILES, the INCHI will keep more information than the SMILE standard. These kind of standards are usually easy to use in any drawing app. So you can do a quick 2D or 3D drawing using these standards. The SMARTS standard is associated to the SMILES. It's just easier for pattern recognition. So if in some kind of project you need to find, I don't know, any molecules that are carboxylic group, then you could use this pattern to find all the molecule you are looking for. And finally, there is another one, which is the selfies. And you can see this is this representation. So that's there is no rule that Aalto gives for choosing your standard, but you should choose one and stick to it. I recommend that you ask your manager what is the standard they use in your team, and maybe choose a similar standard to the one in your team. But the important point is that you should stick to it through your research. So now I will talk about the research data management ecosystem. So if you have any question about research data management, you can go on our online website, or you can send us an email. So we have a global address for questions, which is researchdata@aalto.fi. But you can also go on this web page where you will find all our data agents, and you can contact directly one of us. So why contact one of us? It could be easier to interact with data agents because we are researchers working in your field often, and so we could more easily understand what data you are dealing with and what is exactly your problem. You can also contact research software engineers if you have any problem related to softwares. And we have also RDM trainings online, as well as this one, which will be online later. So here is our network of data agents. So as you can see, we are physically all around the university. So you can contact one of us if you have any questions. So this is all the training. So if you go on this website, you can find all our website training. And if you have any questions about general data management or legal aspects, then you can follow these trainings. So now I will let the floor to Pedro.
Okay, so hello, first of all, to everyone. I will give some more examples on our work life, and I will try to explain more about the process when we first go into data management and after we deal all of these issues. So this question, what I put here is, after knowing what and which are good practices, immediately we can think that we are going to change, right? But in fact, there's maybe some problems associated with research data management, and there are a lot of issues that we need to deal with at the same time, and it also occurs in a specific time of our work. Is not like we didn't start researching about. We didn't have these kind of practices when we first studied, so it might not be, how should I say, like directly starting using. And so I put here some kind of examples. Okay, so we have many different voices calling for making research open or try to replicate all the research. And these are all good movements, but at the same time, they don't push exactly on the same direction. And this might not be too optimal when we face all of these kind of introductions to data management. Another thing is, well, we are talking here in chemistry, but sometimes we collaborate with other people from different fields, and sometimes data is not even easy to define, or how you're going to save it. For instance, how are you going to document in history or in some human fields is completely different from how you document in physics or in math, for instance. So it's not that easy to make a standard mechanism. Another thing is like, well, we can start today, but what are we going to do with the data we didn't document, for instance? So, well, we need to do something about it, or should we not? Or how should we deal with the data we didn't sort it properly? Are we supposed to lose a lot of our time? It's probably not the most efficient. And if you try to change also your practice, but the practices of the people that surround you, this kind of criticism is not often seen as a positive criticism. So people might be not too easy to change about the way they do their science, okay? And also, if you start to preach about good practices, at some point, it's also hard to define because you are writing projects, you are managing people, you are also managing your data. So there's a lot of different ways you look into your work. So at some point, it's also good to have good practices, but it's also good that you are paid, and somehow it's the mechanisms that currently exists to classify you as a good researcher doesn't necessarily go over if you save your data properly or not. So I think there are some problems that make research data management not that easy to implement. So we need to start somewhere, and at least we need to start by ourselves. So this is more or less an introduction to all these practices. What are the basic practices you should at least use in your work? So if I asked each one of you, if you could find a note or details of an experiment or a file in your PC right now, from 5 years ago, what would be the process you would do? Like, would you consult your lab book? Well, your lab notebook from 5 years ago is probably not the currently used right now. So could you even find that lab book from 5 years ago? Moreover, if you use a lab book 5 years ago, it's still with you, or it's with the person you worked with that it's managed your work. So these are very relevant questions when you need to conserve data, or when you need to access to data specifically in time. You don't want to lose too much time looking for it. And also, if you need to share some of the data, I mean, you cannot simply make an appointment just to explain what you did before, because that's a waste of time. If you make some proper documentation, at least most of that person should be able to understand most of what you did in before. This is what you can optimize your time while researching, because otherwise you might lose time on doing things that won't contribute for your work. And this is more like a crash at this point. So if you check on the internet, like during the PhD, you can find like these stories, and you probably know someone that knows someone that get their laptop stolen. And if you check, for instance, on some of these stories, they even give the password and say, please, I don't want the laptop, I don't want anything, you can keep the laptop, but please just send me the thesis for my email. And this could be avoided. Now it's maybe more like people use cloud sharing more often nowadays, but in before that was not. So there was not much cloud services, and these stories happen quite often. And probably there are other examples that still keep happening in this kind of nightmare stories. And I won't to read it, but you can check the stories. They are not fun. I think they are a bit sad, and it's more to us to think. And I put here, you need always to consider when handling your data. It's similar to do a chemical experiment. You need to understand what are the risks. Are they likely to happen or not? And what will be the consequences? Because the consequences of losing like a museum burning and burning all the valuable information is different. For instance, you just make a simple data set that you can just replicate, right? And you don't need to take a lot of measures to everything, but you need to consider what are the risks when dealing with data. So you can have some kind of test of or lose the device where you are storing the data. And your data can also have some kind of become corrupt with time. That is something that has some chances of happening. So it's good you have the backup in different places, and you need to consider that. And it might be, if you don't store it well, it might be difficult to locate it, and you can accidentally delete it. And colleagues might change your data, and they didn't use the correct processes like you, and then you end not having the original files, for instance, anymore. And if there's not enough, if there's not enough documentation, you will need to lose a lot of time to understand what are the data sheets, for instance. And of course, another problem, if you deal with programming quite often, some of the libraries you used before, if they don't work anymore, and you need to have specific information, what were the versions of the software you used. And I put these last ones in red, because if all in black are bad, and well, it's really bad if they happen, but some things can be criminal if you don't handle like the private information properly. And like if you lose data that cannot be used anymore, then it's really problematic, right? So you need to consider what is the likelihood of things happen and what are the consequences. So if you are in the risk matrix, if you are in the bottom left or even in the left, it's okay, you can save your data files in the desktop, because, well, you don't expect to do any documentation of that because you don't need it, then it's fine. But then if you need to take care, it's almost like a very dangerous chemical. It's probably not put your life in danger, but it can put also your position in danger if you don't handle it correctly. And so the question you might ask is like, what are my New Year's resolution? Where do I even, what I'm going to start doing on my practice if I don't do it already? And the first thing you need to consider is like where to save your valuable information. So in Aalto, I'm cropping this from the kind of service we have at Aalto, but I would try to get informed in each of your universities to see what are the options you have, because in Aalto we have some storage that are handled by the services from the university, but we also have Teams and Google Drive and OneDrive, and all of these have different purposes. Some can handle private data, some are maybe not advisable for handling private data. And I can give the example of my group. We decided to use OneDrive and Teams because there are some apps, and we can also use Teams to communicate between the team members and make it easy to share between our group. And we don't have handled any private data. So we decided that this was a good solution for us. But when you try to find a solution for you, there's the home message taking is there are multiple situations, and they have advantage and disadvantage, and you need to decide to your daily work or to your team what is the best scenario for you. And then you need to organize. This is probably not the best way, but at least the way I see my colleagues and people are used to work with is using like a hierarchy of folders. So for each project, you design a folder, and then you create subfolders, and you can use, for instance, this kind of organization where you have, for instance, this red can be only accessed by the PI, and this is where you put the documents related with the project. And then you can have some documentation, some files and documentation that is common between the researchers. and where people put the information in here, and then, and then the green might be the personal work data. So each user then has their own folder where they can organize their files as well. And this is just an example you can follow. You just make the important is to decide in a way of organizing, and everyone sticks to that organization. This is the way of doing it, and you also need to decide how you name your folders so everyone knows how to do it. Another thing is, well, after the folders, you need to also rename your files. So there are many possibilities for naming a file. Here, I think this is like what I would suggest is starting by the date, because then you can have some kind of organization that is time framed. But then you can see that you can put any tags. The important is then there's documentation that accompanies these files that tells exactly what are these files. And here there's a comic about, you can see that there's a story told in the file names, and this is by Pilot Hidden Deeper. And it's very funny because if you don't rename properly your files, it's, well, you end having this kind of, well, starting over after you do everything. So you need to put decent names, and then you need to say what you did, so you can actually make some backtracking of the experiments and try to identify some mistakes, okay? And this is now maybe an example. For instance, this is Pedro, and Pedro is developing some yarns that smell good when you heat them. And so you have a team then where Maria synthesizes the yarn, gives it to Karina to knit a fabric sample, and handles the samples to Pedro. Now, Pedro's job, or part of his job, is to make the thermal measurements. So after he makes the experiments, Pedro needs to share the result with the team. Okay, so this is a typical workflow of what we usually do. We can plan more or less the experiments. We can take some notes. We can do these also notes already in taking the PC. And then we need to perform the experiments. And here, again, it's advisable to take notes. And it would be good if the notes are taken digital already, because it can save you time. But to be honest, if you are in a wet lab or in a lab that doesn't allow to have any laptops, then you need to have, for instance, your notebooks. So of course, in many situations, you need to still to take analogic notes. And then you need to document at some point. The closer to the time you took the experiments, the better. So it's fresh. But if you take good notes, then you can simply copy from one part to another. And then you can still do planning or repeat some experiments, because maybe something went wrong, and you just keep this kind of workflow. And at some point you will share. And this sharing part is important, because you can share with your team, you can share between different teams, and you can also make available in the publication or archive. And all these layers, you might need different type of descriptions. So the best scenario, you have already the most broad description of everything. And this is not as tenuous as it might sound, because if you do every time the same experiment, you might have like a section of text you can use in a template, and then use these templates like from the equipment name and what is the standard procedure. You don't need to write this every time, but you can copy from one document to another, and this saves time to avoid people looking for what were the data sets. So I put all photos and measurements in a shared folder, so everything is fine. And then actually you didn't document it properly. And Maria now is like asking you, what the heck is this? I don't understand what you did. And then you either going to waste more time explaining, and this like what's like the bare minimum practice is write a README file where you put the description of the experiments or the data set or wherever. You can decide on which level you are talking. And the good, the best case scenario would be if you use standards-based metadata. That would make it easy to if there's some typical experiment going on, then people can just understand immediately what you are doing. But what kind of format should be used to create these kind of README files? And well, my advice is to make in text files. You can, to be honest, you can use Word documents, you can use Excel, or you can use PDF or LaTeX. Anything that it works better for you is better than nothing. But text files actually are the easier type of files that can be read in any kind of platform. There's maybe even like a mobile phone or like a Raspberry Pi can read basically these text files. And I also use a variation of the text file that is called Markdown. And Markdown is basically text files, but it has some specific syntax that you can use this syntax to make the documents look better than the plain text file. So this is the plain text file, okay? And this is our typical field you can put about the data set and how do you collect it and what kind of file formats and when it was collected, or you can also put how it was processed, when and by whom was accessed, all that kind of information. You can check here on this link on some standards of basic metadata in here. And this is like now the basic syntax that we use, for instance, in our group. For instance, when you put like this cardinal symbol, you get layer one, you have this paragraph style one or header second level or third level header. You can see that it have an hyperlinks and even you can put some images in here, and it's rather simple and lightweight to use. So this would be the basic, like the better than nothing practice I would advise. Of course, there are other practices, but they are maybe a bit more complex, and this we are talking about where to start, okay? And this is, for example, I take a screenshot of an experiment we did last week, and you can see there's multiple folders, and then there's a README file that it tells exactly what are in these folders and how folders are organized and how videos are organized, for instance. Now, why is this metadata important? So for this part of our presentation, I would ask you to access to this link that will be shared right now in the chat. And I want you to write a message in the box in the top right. What is the information that is missing in this picture? Okay. So in the top right layer box, you can put some message and you can change the color of your message if you want, but just write what is missing or what do you think is missing in this image. So someone wrote already that he's missing the resolution. So yes, someone said very well that I have no idea what this is. Well, me neither. Honestly, I didn't even put a citation properly to this image because I just copy pasted from somewhere and I didn't want to know what was it. So the date of capture. So the image, there's like a saying, like an image worth 1,000 words, right? But I mean, I can say that it's gray at least. So there's already a lot, you understand at the very first second, what was the issue with this kind of image? If there's no scale bar, you are not, probably you can identify it as an SEM picture, but honestly, it might not even be an SEM picture. You are not sure what is it. And what I wanted to show to you is, if you don't put any metadata, if you don't put any description, a very valuable piece of data worth literally nothing. And think about the articles, they contain a lot of precious information. But also, if they don't contain about the data exactly, if someone tried to replicate it, might not be able to do it, and it will diminish for sure the effort of the work, because the scientific method is based on describing all the steps and to be honest on how you made everything. And it's probably you were not lying, but you forget to mention some important step about your work, and suddenly the work cannot be followed anymore. And this is very important. So when you save your data, you do it properly. I will switch now to the presentation again. And so metadata is something that is important as data, as you can see. So this is just a basic example. This is, you are already using metadata in your work when you use the BIP files. They are basically metadata files where there's already some fields here that are the metadata fields, and you just put the article key to cite this data, and then there are these fields that are filled with this kind of metadata information. And then you just can create any references in your articles by using the article key. So you have a library about, and this library is very organized. And the same thing can be used in data sets, okay? So this is the basic information. So now I will just pass the word to Charlotte again.
Okay, thank you. So now we will finish by talking a bit about open data and some tools like the electronic lab notebook. So when you want to open your data, I hope you want to do that. You can use different repository. So why would you want to do that? First, it's because it will be easier to reuse your data. So for the sake of progressing in science, you should want to make your data reusable. And then it will be easier to cite them and give you credit for your data. So it's really important to consider this opening of your data. And this is done through repositories. So you can find general repositories such as Denodo, UDAT Service, or Fair Data Services. Or you can find more specific repository to your field, like the Cambridge repository, for example, for crystallography, or K-Motion for some molecules or reactions. You can find this catalog of repository. Maybe you can find a more specific repository for your field. And once you have published your data, please inform us so that the ACRIS can make a report about this publishing of the data. So this is what Zenodo repository looks like. So it's really a general purpose repository. It's open access. It has been created and it's operated by the CERN. And you can really use it for any kind of data, such as videos, big data sets, research softwares or papers. So it's really, it looks like this. So if you feel like having a look, you can go on Zenodo and see what it can do for you. This is the other example of more specific repository for chemistry. So that's ChemOcean. This is more for molecules, and you can really enter easily all information about your reactions, such as how many grams of which product you put in, and it also uses standards of chemistry so that you can really put in details which chemicals you used, and it makes it easier to reproduce for other scientists. So now we'll talk briefly about the electronic lab notebook. So I hope you are all at least using a paper lab notebook. If you don't know why, it's because you need to keep all your metadata about what you did, what you observed, when you did it, where, with who. So it's really important to keep a lab notebook. And why a paper lab notebook is maybe not the best, it's because it can be destroyed, it can be lost. I'm sure some of you already saw emails from people losing their lab notebook and looking for it. So that's very common, that you put your lab notebook somewhere and forgot about it. So that's really not safe and not very confidential. There is no backup. It's difficult to read, so I'm not saying that you all have crappy handwriting, but it's always difficult to read the handwriting of someone else. So it's also very difficult to search through a lab notebook if it's not yours, because you may remember what you did 1 year ago and where exactly you can find it in your lab notebook. But if you let it to your manager once you leave your institution, then your manager will not lose hours and hours looking for this information. So that's why an electronic lab notebook can be a good solution, because we can easily search through the metadata with an electronic lab notebook. It makes it easy to reuse. There is a traceability. It's easy to share with your collaborator. There is also in some lab notebook time-stamping facility, so it can be used later for patenting. And you can also associate different digital data with an electronic lab notebook, such as Excel files, image, spectra, any kind of data that you cannot really do with a paper lab notebook. So here in Aalto, we have 2 approved lab notebook. We have this first one, the notebook.aalto.fi. It's based on the eLab FTW application. And we have also the AMAD platform with a lab notebook included. So you feel free to test both of these. Here on the side, you have representation of the notebook based on eLab FTW. So as you can see, this notebook is user-friendly. You can see that there is a Word kind of facility where you can write and put images, change the format. You can control who can read your lab notebook, if it's only you or your team or a specific members of a group. So you can create project group. You can put any kind of data, but it's not ready to store data. It's more for quick images of your reactions that you can add in it. And there is also a molecule drawer inside. So this specific lab notebook, as I said, it's based on eLab FTW, so it's a web application. It's completely open source, and there is a great community of users that you can find on GitHub. So it's very user-friendly because it's browser-based, and it's compatible with most device and browser. But it's safe because it's installed on Aalto servers. So if you are not in Aalto University, it's also, as it's open source, something you can get. But for people in Aalto, it's installed on Aalto servers and it's operated by your IT. So it's really safe, and there is an automatic daily backup, and it's very secure for the storage. So you don't have to worry, even if you access it by internet, it's safely stored. So if you have any questions, or if you want to add any new feature to the lab notebook, you can contact the ELN at aalto.fi, and they can help you, on any requests you have related to the electronic lab notebook. So now it's the end of this lecture. So if you have any question about research data management, you can contact our global address or any of our data agents. We have IT experts and legal counsels, and you can also contact the ACRIS if you have any questions related to information specialists. If you have questions related to software, you can contact the software engineers. They have a daily garage at 1. And if you want to know more about research data management, please feel free to go on Aalto website, find our guidelines, and watch our trainings. So thank you for that. And if you have any question, we will stop the recording now and you can ask them.